Awesome. Hey, we're live now. Okay, great. Hi. Hi, everyone. Thank you so much for coming. I'm going to go through some logistics, and then please take a seat. We're starting now. So if you're standing in the back, we have seats in the front for you. Just a couple logistics. We have bathrooms through those two doors in the back. It's propped open, so if the door closes, you will not be able to get it back in, but the event chat is open, so bathrooms are through the back. We have water on its way, but in the meantime, you are welcome to use the cups and fill it up from the water stations. But water bottles are on its way, and then for actual cups, you can go ahead and use the cups to fill up water from the water stations. Okay. And then please, this area is for us, and then please stay from the employee area or like the employee fridge. Okay. Those are just all my logistics. If you want to add anything else on the logistics front,
I think that's
covers it. Okay, great. I'm gonna let you introduce yourself, and then I'll introduce my company and
Awesome.
what we're doing.
Awesome. Well, thank you everyone for coming. You're here at Lightfield's HQ. We are a AI native CRM that basically self-assembles itself and does the work for you. So maybe you guys are on CRM, HubSpot, Salesforce, others. We are CRM built specifically for early stage startups. So many of you guys maybe are founders, early sales, doing founder-led sales. So if you're looking for a CRM that, you kind of want to have it more of that AI native experience, please go ahead and check out Lightfield. You can find us lightfield.app. If you use code LF 30 days, you'll get 30-day free trial. If you have existing data on HubSpot or other CRMs, we have a CSV migration agent that brings all that data in, really nice and easy. All you got to do is connect your email, your calendar, and data basically starts filling out itself. So yeah, thank you guys. Hand it off. Hand it over to you.
All right. Thanks so much. Okay. Hi, folks. I am Yuki. I am with GMI Cloud, which is a AI native cloud, which is doing infrastructure. If you're building agents, it's got over 170 different AI models, both open source and closed source. So this would be including Gemini and Anthropic models, but also includes like DeepSeek, Kimi. And we put together this tonight because we've been seeing a lot of agent builders trying to token max, and we want to support what you guys are doing in this space and bring you together to discuss some of the hardest challenges that you're facing as you're building out agents. And tonight we do have this live streamed, so we will be bringing up 5 really amazing speakers and a couple of breakout sessions afterwards where we'll talk about memory, infra, evals, and you'll have time to do plenty of discussions after these presentations. Other than that, we come talk to GMI afterwards if you want to talk about credits or how we can like support you guys in what you're doing. And special thanks to NVIDIA for supporting this event as well. GMI Cloud is one of 7 official partners of NVIDIA. So we are also providers of GPU. So like if you have GPU needs, come talk to us afterwards. We've got myself, Roan, our developer relations, and also Nicole, who is from our event side, and we'll have our partnerships person, Anthony, and Minjin, who's our product manager, all in the room. So there's plenty of the GMI team to talk to you about infrastructure, GPUs, models, and all that good stuff. And we also have Telnix supporting us, and you're going to hear more because she is one of the speakers tonight. So without further ado, let me first bring up Telnix, if you're ready to come speak. Yeah, can you go first? And I'm gonna ask you to speak into this microphone and stand here so that people can see you. Can I just hold my laptop? Yeah, you can, and yes, you can absolutely. You can clip this on.
Yes, that would be helpful.
I don't know if it's gonna come through perfectly because it's running out of battery. Good enough.
Okay. Don't mind me, I'm gonna shout. So, but
Okay.
it's a friendly shouting so you can hear me. Okay.
If you can't hear, there are seats in the very front row.
I think I need to let in on Zoom.
Yeah.
No, I need you to let me in on Zoom.
Oh.
Yeah.
Okay.
Yeah.
Yeah. Here we go.
Okay.
Okay. And you can my phone so I can see photos.
Yes, thank you. It's just that.
Okay.
Okay.
Yeah. And if you guys want water, we have cups, and there's a water refill station with like the taps next to the kitchen area. But the employee fridge is off limits, but the water taps are really good for water. Cool.
Ready?
Yeah.
Hey, everybody. How's everyone doing? Yeah? Ooh, I love the energy. Thanks, guys. Thank you for coming. Quick introduction. My name is Sonam. I work as a developer advocate at Telnix. And I'm not here to talk too much about Telnix, but if you are interested, come find me later and happy to tell you. But one-liner pitch, we are telephony, telecom company plus voice AI agent platform. Okay, that's enough about Telnix. Today, this is a very different style of event, which I'm thankful to the GMI Cloud folks to come up with this format. We're going to talk about the hard problems. Now, here, my thing is that what happens when an AI agent stops just answering, but starts taking real actions? Because in communication, one small bad action, it has a real world implication. So the issue in hand is basically that whether an agent can the issue is not really whether an agent can place a call, it is whether that action is safe, it's authorized, observable, and recoverable. So this is what I want to talk about today. Here's the shift what that I want to make. It's that once an agent has autonomy, we cannot really treat the model output as we cannot really treat the model output as just the production decision. The model may propose, okay, you take a reasonable next step, call the person or send the SMS update or uh, you know uh, push the workflow or something, but the system basically has to decide whether that action should really happen. Now, that decision depends on things that are outside your model. For example, you think about policy, you think about auth, you think about consent, rate limits, and even logging. Now, the trust boundary, basically, it cannot be the prompt or just the model response. The trust boundary has to sit right before that API call that your system makes. That is the I feel that is the core production constraint that I want to dig into. Now, to make this a bit more concrete, I will use Telnix as the infrastructure surface because, well, I work there and I'm pretty close to understanding what this is about. And so when it comes to communications API, that's where an agent that's where that agent decide or agent decision can turn into a real call, SMS, voice workflow, or even a webhook event. Now, agent would propose the agent would propose the next action, but I don't think that it should be the trust boundary like I was talking about. Before an action reaches Telnix, it it should pass through a production gateway, and that is where I mentioned, it has to be the policy, consent, scoped authorization or authentication, budget, rate limits, etc., and even retry rules. So Telnix is that's where, it executes the communication, and the resulting events, it basically comes back into outcome state or in the form of logs and even memory. Now, whatever you do or whatever you build in the demo, you have some sort of assumptions. And it's not necessary that those assumptions are going to be translated into what the production is going to look like. So tool calls, they can get, over trusted. There could be way too many calls for every little thing. Or memory can become stale. So that already carries a risk with it. Then we have retries. Retries are different when it comes to the agent calling you or sending you an SMS. It is tricky. And then the last bit is the observability. Observability. I hate that word. But then that is often split because you may have model traces, you may have API logs, policy checks, webhook events, but not one clear story of why the action happened and what the outcome was. So the way I think about Telnix and all of this is imagine Telnix as the execution layer for real communication events. Before Telnix, the production system needs policy, consent, scoped auth, and like I said, budget and etc. And after Telnix, the system basically needs webhook reconciliation, outcome state, recovery logic, and more. So the way I would basically frame it is that Telnix executes the communication, the action gateway decides what is allowed to reach Telnix. And so it's like, imagine it as a checklist, a gateway checklist, or rather action gateway checklist, where I want to make sure that, okay, what's allowed? Is this action basically permitted for this agent, for this workspace, or does it require any confirmation or human reviewing? Then we have, you think about, okay, how are the authentication scoped? Or can we reconstruct later what happened? Be it the intent, policy decision, the payload, and of course, the outcome. Now, and if it fails, does the system know whether to retry, to stop, escalate, or ask again? And before I end my talk, the question I'd love to compare notes on with all of you is that where are the teams drawing that thin boundary between agent autonomy and the deterministic control? Because for me, the takeaway is like the agent actions become infrastructure events, and infrastructure events need production controls. So that's my question. I don't know if we have time to discuss it, but come find me later. I'd love to give a chat with you guys. Thank you, everyone. Thanks for your attention. Well, I'm going to steal the time. So, any thoughts? Anybody has worked? Yes.
So actually, we are building a solution to solve the issue.
Mm-hmm.
So we are a team of our three uses PhD, a researcher, we do the best people for this field, and we leverage our research for patients to solve these deterministic control behavior. So what we do is we actually also open sources ranges in 2.5 So we can help compile natural language policy you want your agent to follow, and it will compile them to machine checkable and mathematically provable rules, and effectively enforce it real time. We also test it on some, benchmarks and achieve so output. Like our algorithm already can block more than 95% of these licenses of the 12 million. So if you guys are interested in quantifying.
Yeah, thanks for sharing that. Would love to chat with you after. Yeah. What's your name again? Jonna? Okay. Everybody heard? Jonna? Okay. Anyone else have any questions, comments? Yes.
So, like, say, let's imagine a vending machine controlled by an agent, and it's permitted to vend like $2 pops.
Mhm.
And there was a prompt injection, and now it's vending like $2 pops like 100 times. And like it was authorized, and your gateway was authorized to vend $2 machines, but it's not preventing the vending machine from vending 100 times in an unauthorized way. Right? Like, is there a way to overcome that issue of using like your proposed mechanisms?
I think in that term, I feel like usually the guardrails of how you are setting up in your agent workflow, that generally helps, because I remember somebody talking about a similar example. That's where that's the line, right? I was talking about, like, okay, you have the agent knows what you have set it to do, but then sometimes when is the right time to bring in the human in that loop? And in your example, I feel like the guardrails and having that component, the human component added to it, that might help. So yeah, that's my thought. But I don't know if I can should just hijack the stage. But Yuki, I'm good. Yeah.
Thank you so much.
Thank you.
And thank you, Ptolemix, for supporting this event too. Next up, we have founder of of this really cool agent that does stuff with video games. So I'm gonna hand it over to you. You good?
Can I connect my laptop?
Yeah, you need to connect to your laptop to the Zoom meeting. Awesome. Oh, by the way, we have more time to answer questions while he's setting up.
Oh,
Yeah.
yes.
Go to Zoom.
You can track those because we are connected to different observability and tracing.
Okay, join.
Plus the webhook you can
And join meeting ID here.
Oh, okay.
whatever history of the communication is like step by step. And you can track what your webhook, or like which tool was called, when was your webhook initiated, ended, disrupted, those kind of things. So that there's a way that we can track all the activities.
So like my book basically has to respond. Connect to audio.
No, don't.
This?
Yeah.
Okay.
Okay, and then just you can share your screen. Okay, got it. You're in.
Awesome.
That's a good question. I don't have the exact answer to that, but if I want to take an educated guess, I would say it's like how many
I think, okay.
when you need to update, when it becomes too much for one behavior and another one, that's why you have all these different layers to get to that. And if you improve like policy and all those authentication rules, yeah, that kind of becomes complicated.
Just
You're in? You're good?
Yeah.
Okay, and make sure you're standing in view of the camera. Because you're on live stream. Just stand a little bit back so that it doesn't cut off your head. Yeah.
Okay. Awesome.
And you're blocking the screen a little bit. So maybe stand right here.
Here.
Go to the right of the There you go.
This.
Yeah.
Wait.
Yeah. Good. Good.
Thank you. Nice to meet everyone. And what we do, we build Black Panther
It's AI QA for play testing of mobile games. Actually, I'll need this microphone probably. Check. Everything is good with all the tech? Awesome, awesome. I'm gonna put my laptop here and let's start. Basically, what we do is our AI agents that play mobile games to find bugs. Mostly, we work with Android right now with mid-core mobile games. And right now, our main focus is 2D and 2 and 5D games. And I'm gonna dive in the reason why we're working with this particular type of games right now in our next slides. Uh, Basically, when it comes to the whole process of testing and our AI agents, like two sides, we have like two problems we need to solve. This first one is actually perception of what's actually going on the screen. Because basically, when we have like games, we have live stream in front of us that we need to analyze every second or maybe like a few times per second to understand what's going on. Some of the games could be quite fast-paced and basically need to understand like visual environment and what's going on. But since our agents need to play the game at the same time, test the game, we need also to execute the right steps that will lead to the result we need from our agent. And I would say when it comes to possible challenges, we faced a lot of them. It's like some problems with reliability when it comes to possible false positives. You don't want to send like a lot of them to QA team or they will not use your AI agents. It's actually unit economics. Let's say if you run your agent the same hours as like actual QA, 170 hours per month working with a video stream, it could be like quite expensive. But the problem I want to focus today is latency, which was like quite a pain point for us when we started. Basically, when you have like too much of latency, when your agent can understand the screen and take action like let's say once per 5 seconds. First of all, you cannot test a lot of games because it's going to be like simply too fast for you. But at the same time, when we talk about giant market of games which has like slower paced, where it's like turn-based games, if you like too slow, your time for regression testing of the game, it just like goes to the sky, and like regular tester becomes like much more effective for you. So for us, it was like one of the main problems that we wanted to solve. And to do this, basically, we came up for now with 4 different architectural decisions. First one is data analysis, because when it comes to games, if you'll think about it, every second of the game, we don't have like the full change of state of game. We have like some particular things that different on the screen. So basically, when we can separate what's like actually was like changed, and we don't need to analyze like every screen every time, it helps a lot, both with the cost, but at the same time with the speed of testing. Beside this, it's a compressed observation that we don't send like basically to model like the full screenshot. We break it down on like a lower level at first, and then send it as JSON file instead of raw pixels. Then it's like periodic compression. Basically, when it comes to visual context of the game, it can fill your context like super quick. And if you don't want your agent to fail, we need to save the data in a way that will have like our active contents, which not going to be like too big, but at the same time be like pretty effective with it. And number 4 is like multi-step planning, when we not do like one plan and one execution step, but when we need to plan a few steps ahead. And when it comes to me mentioning that we're working mostly with 2D games, is that when it comes to 3D games, even if you have like simple rotation of the camera and like all the other things in the game stay the same, you like flood it with false delta information, because like basically AI agent thinks that a lot of things like on the game was like different from what was like second ago, when in reality it's like the same. And since when it comes to game market is like pretty huge, right now we focus like on 2D and 2 and 5D games. Since when it comes to working with deltas, it's much more friendly for us. Second, basically, when it comes to compressed observations, that we have our vision pipeline, which pre-processes the screen before like the actual LM sees it. And basically, it's like three main layers of it. The first one is like UI detection. So we need to understand like all the buttons, panels, HP bars, and all the other elements of the game. Then comes like OCR. When comes to numbers and fonts in the games, like all this like gold glowing and things like this, it could be like quite confusing for LM actual model we use. We send they're like not raw pixels, but actual structure JSON file of what's going on the screen. Then when it comes to compression, I guess like no matter how big is the context of your model, you're gonna feel it, pretty quick. That's why when it comes to us, basically it's like varies from game to game, but on average, every 20 steps that we execute, we basically go to lighter LMM to compress, and then basically send all the archived raw data to vector DB for semantic retrieval later on, but we keep our active context for our agents to act on it. And the last one is like actually multi-step planning, because we have a classic scheme of planner, executor, and observer. When it comes to planner, it plans like depending on the game 10, 15 steps ahead. Then executor jumps to it to go through the steps. But when it comes to games, sometimes you can have like some pop-up window out of nowhere, or let's say when it comes to even a lot of like damage systems, instead of like particular damage, you can cause to a monster character, you have like range of what could happen. And if something goes like not as planned, observer let us know and we get back to planning. But overall, like this tactic of planning like a few steps ahead helps us a lot with the latency problem and with amount of times we need to call planner, because when it comes to planner, it's like the heaviest model, which has like, the most reasoning. So it could be quite expensive and long. When it comes to us, obviously we tried a lot of different models and we keep playing with it when it comes to Gemini family, when it comes to Claude. And when it comes to our ideal triangle, it's like basically having enough context, at the same time being good with understanding like visual environment, but at the same time being cost effective. Right now, the one that we use like as our main one is like basically Gemini 3.5 Flash. But the thing that when it comes to all the steps that I mentioned, a lot of things obviously like depends on the model we use. And that's kind of good thing about it, that even if we're not going to change like anything in our system when it comes to design, in half of the year, in a year, we know that it's going to work like even better, because we'll have like new, more powerful models, which will have like less latency, which is going to be like more cost effective, and which will basically help us with understanding of visual environment of the game and testing process. And the main thing when it comes to production software and QA is that right now, when it comes to different models of the market, it's pretty easy to get like to good result. But most of game departments, they want to you like to be like super accurate when it comes to basically false positives, when it comes to time it takes for you to run like regression testing, when it comes to understanding particular system of their game. And basically, that's our goal on what we're working, basically making our AI agents as effective as possible for game developers. So yeah, here we go. That's all. I don't know what's happening right now. Do I like listen for questions or is like next person? Okay, let's go for questions. Uh, like this guy, he raised like his hand first, so.
Always screaming the screen.
Can you repeat? Sorry, it's a bit loud.
Is it visual only, or does my app get to post data back at your agent periodically?
So basic one comes to us, we both like run logs on the background because like some particular errors, it could be like not related to visual um, the visual environment. Let's say you have like spike in your like memory consumption or things like this. So we kind of approach it like from few different sides, and it's not only visual.
How do you handle it when new models come out and you see that it have potential in your software, and you already built kind of the software for other models, and also looking a little bit more in the future, how is your plan to like deal with the issue like new models like change?
Actually, no, it's kind of like this pros and cons. Obviously, when you change like the model, you need to go through like this tuning process, just understand like in which things it could be better, in which things it could be worse, how it's gonna work. You need to change like the whole design a bit for it. But I guess like benefit you're getting from it, for us at least, it's much better than time we invest in it. And I guess we have like no other choice, because there are like a few different companies on the market who do like the same thing, and if we not do it like to full technological capacity of what we can do, they're gonna do it. So we just spend like additional time and we have no choice. Mhm.
Why should I choose your solution instead of like spending 3 days load, like in-game work that can speed up the game to like 20 times on those areas?
Great question. What kind of game we're talking about? No. So what I mean, let's say, when it comes to testing, I would say that we don't build like AI agents for testing. We build like more AI QA infrastructure in a way that run every game and run like every agent. You need to have like separate device. And let's say if it's like studio who like does regression testing, they want to do like regression testing like every 2 days. You need to run like a few different agents in parallel and coordinated between each other, because when it comes to regression testing for games have like frequent live ops and who like rely heavily on monetization, you have like very little limited window for testing. And I mean, you can vibe code it for your specific game, but you will not have like hardware infrastructure, if it makes sense. It's like the first thing. The second thing is that when it comes to us, we have kind of this data moan in a way that like working with many different games, testing like each genre, we understand like better how to navigate it in the way that is gonna work much better than out of the box decision that you can do like in 3 days. And the last screenshot that I've showed, basically, yeah, you can like pretty easily get like to this thing like, hey, let's vibe code tool, which will do like screenshot. We'll send it, to executor, and we'll decide how it's gonna act. But when it comes to you, let's say like doing the right thing only in 90% of cases instead of 99 and 9, it will have no enough production value, if it makes sense. If it's like commercial games, if it's not indie games. Mhm.
I'm a bit surprised because here you're talking about gaming.
Yeah.
There is an environment, and usually the approach that is used is reinforcement learning, where agent learns from the environment. And here it seems that you're using a reasoning engine from LLM base, right? You collect some data and you feed that. So why are you not using reinforcement learning, for example?
Absolutely. Can you repeat the last question?
Why are you not using reinforcement learning? Essentially, two agents playing against
Yeah.
each other, learning from each other, and they get stronger over time, right?
So I would say when it comes to us, we try like different approaches, trying to solve the problem and problems we have like from different angles. Like the way how we designed right now is like the one that we found like the most beneficial, what I can right now say since like commercial software, but it's like what works for us the best, like from testing again and again and again. Mhm. How like JSON looks like? You mean like when it comes to the basically understanding what's going on the screen, or? No, so if I got your question right, let me get like back to this screenshot. Where is it? Yeah. So basically, yeah, to analyze full like every screen, since we have like a lot of different objects, and we need to be like fast, it could be like quite problematic. That's why we built like this visual pipeline which like pre-process it. But if you think about the state of the game, let's say you're looking at the screen and basically you have things in Bell which like doesn't matter. Let's say it's like some beautiful skyline and things like this, but you have like 3 monsters in front of you. You need to kill like one of them first based like on the logic of the game. At the same time, maybe like your health's going low and you need to do like healing potion, and you can describe all the things kind of in text, and then when you send it like to planner, it could like make logical decision what should be done. So basically you can plan things not like based on the visual picture, but like on the logical context. So sorry, somebody's talking.
Yeah, awesome. Okay, ready for the next person?
Yeah, please come up.
He said it. We're gonna do break just to let you know the format. After all the speak, oh, you probably need a mute. You probably need to turn off your mic. Okay. After this, all of this, we're doing breakout sessions, which means you have plenty of time to speak to everybody on all of the speakers. So yeah. Now try again, but turn off your video and audio.
Let's see if we can do all of this at the same time. Yeah. You want to handle that for a second? Thank you. Okay. And yeah, I have to reconnect to Zoom now. No.
Wait, are you not in? Okay, good. No audio and no video. Okay. Great. Join. G2G.
We did it.
Don't test speaker mic.
I won't.
Okay.
All right. I do have to turn that off. Yeah, I don't know. Yeah.
Cool.
Okay. And
Okay. Just
we'll start here. Yeah, because that makes more sense. Is there a podium or something for this?
no,
Computer?
there's no podium.
Oh, okay, great. Awesome. Very cool.
Wait, this is your demo?
Well, no, I'm starting off here and then I'm gonna, yeah. Hi, everybody. My name is Alex Newman, and I am the founder of Claude Mem. It is a context management plugin that keeps memory from one session to the next in any agent like Codex, Claude Code, anything like that. Does it automatically, does it in the background, and it's fully free and open source. Available also for you to build into your agents. I'm coming out with an SDK that'll make that a lot easier, a lot lighter, and you could just import it and it'll work. But today I wanted to talk about something a little bit different. So I'm super into robotics personally. I love robots. I think it's super interesting. And I was accepted into a YC like robotics hackathon about a month ago. So spent the whole weekend working with these little like kind of Wall-E, Johnny Five little robots. and I learned a thing or two about the NVIDIA stuff on it and the Jetson, how to connect to it, and robotics, and I wanted to share some of that with you guys. So, let's see here. Okay, great. By the way, this is how I learn everything now. I made a skill. I've been doing this, like making these like notebook LM decks for everything. And I've been doing it for the past month. So I had to automate it, right? I had to make it a skill. So I made a skill, and now you can do PowerPoint in Claude Mem, and anything you work on, it will make you automatically one of these. You just log into Notebook LM with the CLI, and it'll bing, bang, boom, do the whole thing. It seems a little bit cheesy or whatever. I think I solved like a 5-month-old bug today by looking at like a little icon of like observations, like all like stormy with like a little smiley face. That visual spark got me the understanding that like to fix this entire like 5-month whole bug thing. So it's like this really does actually help me learn, right? So where are we at here? We had the robot. I was hooking it up. I was trying to figure it out. I know nothing about robots, but I know about Claude Code, and I know about Claude Mem, and I know how to read a code base. So I pulled the code base, and I said, read every file, and like basically it will learn everything in terms of like what all the files do. What Claude Mem does is every time you open up a new file, it shows a timeline of everything that you learned for that file. So by reading the entire code base, I now have this like compact set of observations that already is an understanding of like how to work with it, right? When it goes to edit or read a file, it already has that pre-cached cognitive instruction set. So let's see here. So the way that this particular robot worked is that it has a Jetson Orin on it, I guess 8 gigs of RAM, and that is a skills executor. So all the robotic parts, the movements, the eyes, VLM, a bunch of stuff, all of that is skills. Now, because the skills correspond to moving the robot around or like using it, if you can get Claude Code or an agent to use it, then we're going to have a good time, right? We're going to be able to just like tell the robot to do stuff and it can just do it. But easier said than done, right? They had their own model running on like GPT 4.2. And it was buggy for everybody, right? Like it wasn't doing what it needed to do and people were having trouble. So yeah, all of the perception, motion, everything happens on device, and the voice and the mind was happening from the cloud, the hybrid AI. That was their model, their basic agent that then controls the on-device Jetson. Lots of stuff going on in that robot, right? I was able to take all of the data, the telemetry from the bot and pipe it through Claude Mem. And it actually, Claude Code was like, this is a lot. Let me filter that. And then suddenly it like, it's kind of mind opened up and it was able to like pinpoint different things and start to record like actual like telemetry and everything as I was driving it around or telling it to speak. It would start saving these kind of background memories. And by the way, the memory writing is only actually just from hooking the bot up to Claude Code, and then whatever was happening from the bot to Claude Code was then being observed by Claude Mem, writing the observation. So like the hookup to the bot, it's just a skill, right? That's the big unlock here. And this is a pretty like incredible little device, right? Like it's not so useful right now. It's like a little small thing, but one team had bomb defusal. Another team did prescription drug picking with the onboard VLM. I didn't know anything about that. But what I did know was it did 7 or 8 things, and one of them didn't work. The arm didn't work. Like, okay, well, you're a robot. You need a robot arm, so we need to get that to work. Let's see here. Yes, it's not here. Well, I'm going to show you the video. And I guess I'm not showing you the video. I am. So what's happening here is I actually told it that its arm wasn't working. And I said, told its arm wasn't working. And I sent it a picture of it because I wanted to see if it could say that. So it's now looking at the picture. It as an agent itself, like embodied itself, right? Like it started talking as if it were it. The arm fault image loaded, arm immobilized. Yeah, so it found out that it needed torque. The torque was off. So then it surprised me. Now I'm better.
So right now what's happening is Claude Code is debugging his arm rotating. Okay. Let me show you what I see.
He says I can move.
What the fuck is doing it?
Let me show you what I see. It takes a photo, and now I have a multimodal thought in the background, right? With a link to the photo, the telemetry of the arm, the announcement of the TTS, all in a single line. We take those multiple thoughts and now we can run like infinitely on device, and it'll remember when it picked that prescription, right? Like instantly, and be able to get details. And I was very, very, very excited to be able to do that. And yeah, it all came from like just diving into like a really hard problem. I knew nothing about it, and now I know a bunch of stuff about it. And all I needed was like a Kawaii slide deck to teach me. So that's where I'm at. I think that should be it. Is that 6 minutes? That's probably 7. Those probably 7 minutes. Take questions or even just do it after if you want. Anybody have like a couple of questions? Yeah.
Just trying to catch. So the JSON launching around the on-device and on this local memory. So it stores all of that. As you mentioned, Discovery is able to do that, and then it proceed to all the sudden Discovery keep moving forward with the more.
Yeah. So there's a few different routes that you can take in terms of like running the cloud stuff. And I've been working with a woman who actually won the DeepMind track of that hackathon, where she made the robot be an assistant to her friend Ruby, who has I can't think of the cerebral palsy, right? I'm working with her on it and kind of coming up with the idea that like you can't have everything necessarily on board, but if you have like a home brain like a Mac Mini, that can be like the memory and everything. Because the onboard stuff, at least for this, I thought it was very much like reserved for motion and perception and all of the robotic movements that it's going to need to do. But then she was saying that she actually did use on-device Gemma, and move the bot around and do all the stuff. And that's why she won the DeepMind Award. So, next time use Gemma, I guess. Yeah. Well, we're gonna just we'll take questions in a breakout.
Awesome. Okay, you're good. All right, so so we have our next speaker who is from Tiny Humans, and thank you.
Yeah.
And we're live streaming this for your.
Okay, fantastic.
And there are seats in the front. If you are having any trouble hearing, there are 4 seats here. Please.
Okay, I hope you guys can hear me loud and clear, hopefully. In the back, can you hear me? Yes, okay. I will try my best to shout from my 4 lungs. So yeah, let's see here. Okay, guys. So I just made this presentation 10 minutes ago. So really apologize if it doesn't make sense. It's in Comic Sans as well, but I'm just going to talk maybe a minute about what is Open Human. Open Human is this thing here. This thing is going to take over the world, like every AI founder believes, right? It's an AI agent harness like OpenClaw and Hermes, but it's so simple and easy to use. So that's Open Human for you. But I'm not going to talk about Open Human. You guys can Google it or go to GitHub. It's trending right now. What I'm going to talk about is how to solve hard problems, which is, I guess, why most of you guys are here. So, okay. All right. So I'm going to talk about 2 things that you guys can do to solve really hard problems. The first is why you should go open source. And the second is why you guys should compound. These are 2 things that I've learned in the last 4 weeks that has drastically changed the way I have built products. Okay, so why should you go open source to solve hard problems? The problem is that everyone can create software using Claude, Codex, Cursor, Gemini, whatever. Building tech is so easy, like there's no point in innovating on tech now. This is an example of Monday.com. Monday.com is some, I don't know, $1 billion, company. Somebody wipe coded Monday.com and crashed their stock price by 30% or something. So wipe coding tools like Claude Code allows programmers to build software from scratch and not pay Monday.com. Tech is no more a limitation. There are way too many AI startups out there. If you have an idea, there are 10 other people kind of doing the same thing with Claude and Codex and whatever. There's so many AI startups that there's more that investors can kind of fund, right? So if you don't go open source, guys, sorry, open source is going to kill you. This is something you guys should kind of worry about. Okay, so the solution is don't fight open source, embrace it. Go open source. And why? Because open source projects, especially in AI, get a ton of love and traction, especially on Twitter. Twitter and X loves open source projects. So guys, you stand a huge benefit if you kind of go open source. And I am the perfect case study here because 6 to 8 months ago, I decided to build my AI assistant project, which is now called Open Human. And it was closed source until OpenClaw came out of the blue and just took my lunch, basically. So, so in Feb of this year, I decided to embrace it, kind of go open source. And I had no users, pivoted like 8 different times, right? And the logic is that if I'm the fastest person in the market, and if I'm open source and I can iterate at a speed that is almost impossible to kind of beat, I will win. So this is my logic in thinking of how to go open source. And the result is for 3 months, I built openly, Open Human in the public until April 22nd, which is, I guess, a month from now, a month ago. someone tweeted about OpenHuman and everything kind of exploded. So I'm going to show you a bit about that. We became the #1 project on GitHub for 9 days in a row. If you don't believe me, this is my Twitter. It's like the pin tweet. For 9 days, OpenHuman became the #1 project on GitHub. And that's not easy. That's quite hard to kind of do, right? We became the #1 project on Product Hunt. Well, it should be Product Hunt. I just made this like 10 minutes ago, so sorry about the delay. We're #1 on the daily on Product Hunt, #1 on the weekly, and on track for being the #1 product of the month on Product Hunt. This is again going open source, right? Again, if you want proof, that's like the GitHub. So the point is that open source also gets you a lot of people contributing to your code, which is brilliant because that lets you iterate and grow your project at a speed that is quite insane. Okay, and these are the contributors. I'm only paying salary to like 4 or 5 of these guys. The rest of them are doing it because they just love open source. And this is my recommendation to you guys as well. These are my competitors. They're both YC startups. The one below raised $25 million. The one above is something called Clicky. They just got accepted to YC. And that's me. I have raised $0 in funding. I'm not in YC, spend $0 in marketing, and I'm just eating their lunch. So yeah. This is why going open source is super awesome. I got 41,000 users in 2 weeks of launch, which is stupid, you know, like I don't know how we get those numbers. Okay, the second tip I want to give you guys, and this has taken 10 years of my life building products and being an entrepreneur, which is you should learn how to compound your value. And I'm going to explain this idea in a bit. Compounding is something a lot of investors might know, but it also applies, in my opinion, life and in building products as well. So what's the meaning of compounding? It means that you do small things that work so well, right? Small things that work so well that you never have to look back. So you do it so well that there's no chance of bugs or whatever, and you never look back. And you just keep building on top of it. That's how you compound, right? So compound is my secret, second biggest secret for why we're getting so much traction. And what happens if you go open source and you compound? Well, I spent, as you know, $0 in marketing, raised $0 from VCs. Revenue, I generated $40,000 in a week in just 2 weeks of going open source and compounding value. And as of yesterday, I decided to raise $2 million. As of today morning, I've raised 1.5. So it's just kind of stupid how much that's been. Yeah. So these are my 2 biggest tips to you guys. I would highly recommend you open source and compound. What else can I share? Reach out to me. If you guys want to get connected, I'm super open to helping out, super open to sharing time, contributing. So that's me on X, and that's me on LinkedIn. And that's it. Yep.
Thank you so much.
Yeah.
Right.
Yeah.
All right. Next person is from our team, Minjin from GMI Cloud. Thank you so much. Yeah.
I'm actually going to show you guys something confidential. We have never released to any of people that is outside of the company, and I'm actually playing around with it right now. And yeah, I'll starting with showing my screen. Yep. I was actually playing around with it. It is called Agent Box. As you guys may already know, we are a cloud infra company, and we sell GPU on the cloud. We do inference, and we provide infrastructures. And right now, we're shipping a new product that is called Agent Box, which is hosting agentic infra on our GPU clusters, which is backed by NVIDIA. And this is a page where I have deployed several of my self-use agents, like the PR reviewers, the SQL Copilot. I'm using it. I'm using this observability page to see all the logs, monitoring all the memories, and most importantly, it also does track what is other people's impression of my agents. And okay, I'll actually start before I demo this product to you guys. I'll be showing you guys a little story that I have out of my own. So it was a worst email I've ever received on a Monday morning. It was my founder friend who emailed me about he got a cloud bill and saw there was about 40K bill of he's running his agent on cloud, and he does not have that amount of user as Steven does, as Tiny Human does, but the number is still crazy. He didn't expect it to be happen that much, but as you guys may already know, if you're building an agent, it's running like sometimes 24/7. So it's hard to do the cost control. And that is actually a story that inspired us of building this product. We help people to deploy their agent on cloud. We help to do the cost optimizations. And most importantly, this is a place that we help you to distribute. And yeah, I'll first start with this marketplace page where you could see all these wonderful agents that is in the marketplace. And there are two paths when you enter this platform. You can choose to deploy your agent using our infra, or you can just simply come in and browse over all these amazing agents using powered by GMI's infrastructure. So when it's launched, you will be able to see amazing agents like Tiny Human, who is published here. They're also one of our partners. And it's really simple. We also have a register an agents. We call it deployment wizard, where you could just simply input your register your Docker image or your code to upload it to us. And also, you're able to use our model as service platform here as well. It's super simple. I really wanted to show you guys this. And for example, I'm just gonna call my project name. And when I click continue, I can upload an image. I choose the data center, the compute tier, and I can choose the model that I wanted to input into this this deployment. I'm just gonna copy a image of my project.
Is that Docker link?
Yeah, it's a Docker link. And when I click continue, oops. Oh, I forget to choose the compute here. And we have more than 100 of models, LLMs, in our model library. So you're feel free to browse all of them over. And then here, I am just gonna choose DeepSeek because it's cheaper. And when I click continue, we inject all the environment variables in it. You can also add one yourself. And also review all these informations. And when I click register, it's registered in Agent Box, and you can call this by using the APIs that we provide. And most importantly, when you register them, you can list this agent in the marketplace. That means you can distribute your agent in GMI Cloud's channel. I've seen a lot of other agent infrastructures, but none of them are doing this. And I have to tell you guys, we are having more than 10Ks of traffic in our landing page, which I think is an awesome distributing channel for starters or agents builders to advocate their product. And yeah, this is our product. And also I wanted to show you guys a little bit of information on why building on GMI Agent Box. First of all, is our marketplace flywheel. We do day one distribution. As long as you deploy, you can distribute on Agent Box marketplace. And we definitely have the isolated environment for your agents. Most of the people are really aware of the data security. That's totally fine. We got it all. And also we do have 24/7 backend support, enterprise levels of SLA, which a lot of you guys might already know that we are super specialized in enterprise services. Yeah, and also our agentic ecosystem, from the first layers of compute, sandbox, to the orchestration, agent runtime, security, observability, we cover all, and also memories and tool access, MCP. These are also on their way. Yeah, and just to also give you guys a little introduction on our ecosystem and integration, we are one of NVIDIA's 6 reference partners. So that means if your agent is running on GMI Cloud's infrastructure, you're also backed by NVIDIA. And we also support built-in open source frameworks like OpenClaw, like TinyHuman, and we also have more than hundreds of models in our GMI model tracker. Yeah, and if you're interested in this product, feel free to scan this QR code to have the early access of it. And I will also be hosting a breakout session later, focusing on cost optimization and infrastructure. If you're interested in how do we do this cost optimization, feel free to come by to my breakout session. And by the way, just to let you guys know, some of our partners and clients have mentioned using our agent bot have saved them 2x, sometimes 4x savings in their cost. So if you want to know more, come to my breakout session. And yeah, that's it.
All right, thank you everyone for, those are all of our speakers. So what's happening next are our breakout sessions, how that works. So we have 4 groups for facilitators for the breakout sessions. We've got Minjin, who's gonna talk about infra. We have Ryan, raise your hand. Ryan's gonna talk about cost. If you're a token master, go talk to Ryan. And we've got one more from Roan. Roan, raise your hand. Okay. Yeah, everyone's gonna talk about deployment. So everyone's got their own, but you can also organize with the speakers as well. So we've got, if you're a facilitator of the breakout session, raise your hand again. Okay, 1, 2, 3, 4. Okay, the way it works is y'all will come, have a chance to share what are the hard problems you're working on. This is really a time for you guys to share, not just, it's not like you're listening to somebody, but it's a time to actually have discussion. So the facilitators will be asking you, like, what are you working on? And it's a chance for everyone. So it's actually better to have a smaller breakout session so that everyone has a chance to speak. And we have one more on memory. So Claude Mem, yeah. And we have also one more, if I know last time memory was a really popular topic. So we have another person who can talk about memory as well. So yeah, Matthew is also here to talk about memory. So if you have 2 people to talk to about memory and context. Any questions about how the breakout sessions work? Okay, cool. Thank you so much for joining us for this session. And if anyone's interested, we're gonna leave the QR code up here so that you guys can sign up.
For early access, this is non-disclosed to any of other people. You guys are the first.
And also for early access, we're distributing free credits and free Docker container usage. So whenever you guys have are building or know someone who's building an agent, please feel free to reach out or share this code to them. Thank you.
Thank you. Cool. All right, let's go. You guys okay? Okay.
Breakout session here.
Okay. Hi.
We're hosting a cost breakout session.
Okay. Yeah.